All right, so if you look at the agenda from this week, okay, we are continuing on with the standard that we did the last 2 weeks, 6AF 5, okay, where we're solving equations that have a variable on one side using addition, subtraction, multiplication, and division. All right, I broke those up into 2 separate weeks, 2 separate CFAs before. What we're starting today is that second standard, 6AF4. Okay, and I want to read through it so you can kind of understand where we're going. Carter, I need you that way, please. And we're taking notes, so I need your notebook out, please. That's why I asked that several times. So 6AF4 says what we're going to learn is understanding that solving an equation or an inequality, that's what we're getting to do today, is the process of answering the following values for a specific set. If any, make the equation or inequality true. So to do that, you are going to use substitution to determine if a given number in a specific set can make the equation or the inequality true. So we're taking what we learned the last 2 weeks with 6AF5 and applying it to inequalities with 6AF4. Okay, so that's what we're getting to today. Now, tomorrow what we will be looking at is using what we're learning today with inequalities and applying it to graphing inequalities. So, what is an inequality? There are 4 different signs that we will be using, okay? 2 of them we've looked at before. What sign is this one? We've looked at 2 of these before. Aiden? No? Mason? That one's less than. How do we remember the difference between these 2? What was the little trick I told you? Jillian? Less than makes a no. Okay, now that is going to be slightly different in a second when we look at some of these inequalities, which is what makes this a little confusing. Okay, then you also have something like this. So there is an additional piece to this less than sign that is taken from another sign that we use frequently. And that is this line here. Anyone know what this sign is called? It's combining 2 different symbols together. Anyone have any idea? Not sure? Okay. This one is less than or equal to. This symbol, which we've used this year. What is this one? Ayanna? That one's greater than, absolutely. So using prior knowledge that I just taught you from the previous one, what might this one mean? Adam?
Greater than or less than?
No. You're on the right track. Use what we did just a few minutes ago. Jude?
Greater than or equal to?
Yes. So we've got part of the equal sign. So this one would be greater than or equal to. Now, here is where inequalities can get confusing. Okay? Sometimes these signs can be switched and it still means less than if it's turned the other direction and looks like a greater than sign. And this will make sense as we do examples. So, one thing you have to pay attention to when you are reading inequalities is you read from the side that the variable is on. Okay, and again, this will make sense as we do examples. You read from the side the variable is on, and I'm going to give you some examples. Okay, so if we have this, we're reading from this left side, like we always read in America, from left to right, because the variable is on the left. So this would be read as x is greater than 3. Now, we could reverse that and write it this way. Okay, two different ways you can read this. And this is where inequalities can get confusing. If we read it from where the variable is, this would be x is greater than 3. Okay? Or you could read it differently. Just hang on a second because I know what you're thinking. Okay? If you read it left to right, that is 3 is less than x. Okay? So you'll see why if you're reading from the side the variable is on, get my pointer out of the way. Okay, this can get confusing. So we really have to think about what is written. This equation here could be read two different ways, and it means the same exact thing. X is greater than 3, or 3 is less than x. Okay? If x is greater than 3, it makes sense that 3 is obviously less than x. Do we see that? Okay? It'll make sense also as we do examples with real numbers. So, most of these can be read two different ways. That's why this sometimes can be confusing, and it kind of goes back to where your elementary teachers always said it opens towards the larger number. So here it's opening towards the x, so the x is bigger. Here it's opening towards the x, so the x is bigger. The 3 is smaller. So I think that's why a lot of times they use those signs, or they explain it as it opens towards the larger number. If you're reading it from the side that has the variable, this would be read as x is greater than 3. This would be read as x is greater than 3 because you're reading from the side that has the variable and it's opening towards the x. Okay? So what we are going to look at is actual equations that use inequality signs. Yes, Brielle.
So for the first equation we did, could it be 3 is less than x?
Absolutely, yes. Because if x is greater than 3, then obviously 3 has to be less than x. So you see how you can read it from either side and it changes what that sign means? That's why this can sometimes be confusing. You really have to understand how these two things are being compared. Okay? So that's just one example. There are many other different scenarios. So you really have to understand what those inequality signs are meaning. So what you are going to get are questions like this. And if you kind of glanced at the IXLs, you'll kind of know what is coming this week. So, nice and simple thing that you will get with inequalities. This one isn't too bad. You go about solving these same exact way we solved problems the last 2 weeks. It's just we're not going to have an equal sign. We're going to have one of 4 inequality signs. So it is going to be super important that you guys divide these problems where the inequality sign is. That's why I tried to get you to do that the last 2 weeks. Several of you did not. And even though I consistently reminded you, divide it at the equal sign, divide it at the equal sign, some of you didn't. And that is going to really mess up these inequalities. The very first thing you should do with any equation that you're solving is split it where the equal or the inequality sign is. So forget that this says less than for now. What are we doing to solve for f? What we did the last 2 weeks. Do not let it mess you up that it now has a less than instead of an equal sign. How do we get rid of an addition of 2? Aiden? From both sides. Nothing different so far. All we're left with over here is f. All we're left with over here is 7. Nothing new. Same exact thing we did the last 2 weeks. Now, what you are bringing down is the inequality sign. Whatever it was. Now, this problem you are going to read from the left to the right. And I'm going to write out how you read it so you get used to seeing it. I would write it in your notebook. You will probably want to look back at your notes when you're working on these for the next week or 2. Someone tell me, how would we read this one? Starting from the side that has the variable. Olivia. Perfect. And I'm going to write it just so you have it, because I know a week from now I wouldn't remember what someone said. F is less than 7. So if F needs to be less than 7, there is an infinite possibilities of what F could be. It just needs to be less than 7. That is why these are called inequalities, because we don't have one specific answer. Now, what's going to be easier is tomorrow we'll learn how to graph them, because the best way to show what F can be equal to is to actually graph it. Okay? What would be a possibility for F? If F needs to be less than 7, there's an infinite number of possibilities. What would be one possibility? Jude?
4.
It could be 4. Sure, it could. Because that is less than 7. What else could F possibly be? Every single one of you could give me a different answer and it could be right. Anna?
1.
1. Sure, because that is less than 7. Carter?
6.
6. Absolutely, because that is less than 7. Okay? Aiden?
2.
2. And I'm going to throw one more in there just so you realize this exists. Negative 50. All your negative numbers. Anything less than 7 could be F. 6.999999999 into infinity could be F because it's less than 7. That is what that symbol means. Does that kind of make sense? Okay. Here in a minute, we'll flip the sign and we'll make it all nice and confusing just so we can see those too. All right. So let's look at a different example that's not super confusing. N plus 3 greater than or equal to 6. Okay. Again, don't let the inequality make you think you don't know how to solve this. You do. We just spent 2 weeks doing it. Most important part is that you divide it at the equal sign or the inequality sign. So what would I do to solve this if it was an equal sign like we did the last 2 weeks? What do I have to do to get rid of that addition of 3? Anaya? Yes. Do the opposite of what it says. So I have n and I have 3. That is absolutely nothing new. Now you're bringing down the sign that it had. So someone read me how this would be read correctly, and I'm going to write it just so you have an example to look at. You will not always have to write how to read it. I just want to do it on a few of them so that you have something to look back at. Kylie?
N is greater than 3.
You got half of it. Jude?
N is greater than or equal to 3. Okay.
Okay. That would be read as n is greater than or equal to 3. We have the or equal to part because we've got part of an equal sign. So what is the biggest number or the smallest number n could be? If n needs to be greater than or equal to 3, what is the smallest number n could be? Okay, listen to what I'm saying. N has to be greater than or equal to 3. What is the smallest number n could be? Evie? 3. Absolutely. And then anything bigger. Because n has to be greater than or equal to 3. So here's what that means. If I put 3 into this equation, is 3 plus 3 greater than or equal to 6? Is 3 plus 3 greater than or equal to 6? It's equal to. And then anything bigger than that is going to be greater than or equal to 6. 3.1 would give me 6.1. 3.2 would give me 6.2. Those are all greater than 6. Right? Questions? I know questions usually don't come till we're actually trying to do this on our own. All right, now I'm going to flip the sign, flip the whole way that this equation is written. Okay, so if I have 17 needs to be greater than or equal to 11 plus x. What is the first thing you should recognize about how this is written? First thing you should recognize about how this is written compared to the other two. Aiden.
That there is greater than or equal to sign.
Okay, which we didn't. Well, we used that on number 2. What else should we notice is different about how this equation is written? Which is what can possibly make this one a little more confusing. Which side's a variable on?
Right.
The right instead of the left. Okay? That kind of changes how we have to think about this. Doesn't change how we solve it. Okay? So just like the last 2 weeks, we're going to split this where the inequality sign is. How do I get rid of this positive 11? Aiden,
Can you subtract it?
you're going to subtract it just like we've been doing. So we're going to have an x and we're going to have a 6. That is not new at all. Then you bring down the sign that is there. So if we're wanting to know what x could be, you need to read from the x side. You can't just look at the sign. So if we're reading like the Arabics read, which is backwards order from us, they read from right to left, and that's what we're going to do with this. How do you think you would read this? Being careful it's not what you think because it's backwards. Olivia.
X is less than or equal to 6.
Perfect. Okay. X is less than or equal to 6. Because I'm reading from where the variable is. You could also read it as 6 has to be greater than or equal to x. But I don't care what 6 is. I want to know what x is. X is less than or equal to 6. So what could x be? If x needs to be less than or equal to 6, what could x possibly be? What's one number, Kylie? There's an infinite number of possibilities. What's one?
6.
It could be 6 because it says it could be equal to 6. What else could x be? If it needs to be less than or equal to 6, what else could x be? CJ?
Any negative number?
Any negative number, because that is less than 6. Okay? And then any number from 0 to 6, basically. Any number from 0 to 6, as long as it is less than 6. Okay? So 1 would work. And again, there's other possibilities. You can always check yourself. Let's say for some reason you thought x could be 7. If I had 7 and 11, that gives me 18. Is 18 less than or equal to 17? No. So it cannot be 7. But it could be 6 because 6 plus 11 is 17. 17 is less than or equal to 17. When the variable is on the right-hand side, you have to be careful with how you read the inequality sign. Read from the direction backwards. Okay? Again, I know questions come up more when we're actually working on the assignment. Okay, so I want you to open your book to 621. I want to talk about a couple of those or do actually 2 of them together. 621. Don't tear it out, please. Okay. Okay, so I just want to look at a couple of these. And this will be just a completion grade, all right? I don't hardly ever take an actual accuracy grade the first time we do something. And I know inequalities can be a little confusing to start with, okay? So, number 1, this is how they have this written. Okay. Sorry, that is not. I don't know what I was looking at. That's how they have it written. First thing I would recognize when I'm doing something like this is, where is my variable? It's on the left, like we're used to. So nothing is going to be backwards or odd about this. Okay. So you will actually solve the inequality right in the space they're giving you. So again, we divided at the inequality or equal sign. Even though there is not a sign in front of this one, if there is no sign, is that one positive or negative? If there's no sign next to a number, does that mean it's a positive or a negative sign? Number, I mean. It is positive. So how would we get rid of a positive one? Was the opposite of adding one, Aiden? Absolutely. Both sides. So we're left with F. Thank you. I was solving it and not writing what I was supposed to be writing. That is what we've done the last 2 weeks. Nothing new at this point. Okay? The sign is what is new. Okay? But that's not all they're asking you to do on number 1 and 2. How would we read this? And again, you don't have to write it. I'm just going to put it for now. How would we read that? Variables on the left, so it's nothing backwards. It's just what it is. Adam?
F is less than 6?
Yes. Okay, that one's just normal because the variable's on the left. So then the second part of what they're asking you on number 1 is, what of those could F be? They gave you a list. They want to know, could F be 5, 6, or 7 based on what you just figured out? If F needs to be less than 6, which of these could F be? Evie? That is the only option because it is the only one that is less than 6. So you have to solve the inequality first before you know which one it could be.
So do you put 5 in the space?
You would put 5 in the space. Absolutely. Okay. You have to solve it first, though. That's why they give you the big area to solve the inequality. Okay. Common sense should also tell you, if I put 6 in for F, well, 1 plus 6 is 7. 7 is not less than 7. If I put 7 in for F, 1 plus 7 is 8. 8 is not less than 7. Well, those two can't be right. But you need to solve the inequality first. You don't have to write how to read it. If you want to, just so then you know and it's better to understand, you can. But you don't have to write that part. And then you're figuring out, of the options, which option makes the statement true. 5 is the only one that is less than 6. Okay. Now 3 and 4, you're going to solve it and then just put yes or no. They're giving you one option. So on 3, you'll solve the inequality, and then they want to know, could Q be 20? Either yes or no. On number 4, you'll solve the inequality. Could T be 28? Yes or no. Okay. Then if we look at the story problems at the bottom, number 5, there's not necessarily anything you need to solve for 5 and 6. You're just reading the information they give you and answering a question. So in 5, it says, the table shows the number of different types of roller coasters in the United States. So you have sit down that are steel, sit down that are wood, inverted, meaning they go upside down, flying, stand up, and suspended. Okay, so 6 different types of roller coasters in the United States. There's an amusement park that wants to build a new roller coaster. They will only build a roller coaster if there are less than 10 of that type in the United States. Okay, why do you think that is? Because if they build something that there's already a lot of, is that going to draw people to that amusement park to ride it? No, they want something that's not as common. So they will only build a roller coaster that has less than 10 in the United States. So which roller coasters might they be building? That's all you're figuring out. Which roller coasters might they be building if they will only build one that has less than 10 in the US already? Brielle, what's one type they might build? Stand up. That's why you're going to write on the line. What's another type that they might build? Adam?
Suspended.
Yes, because those are both 5 and 8, which is less than 10. That's all you're putting for number 5. Stand up and suspended. Because those are the only two that are less than 10. Okay? Yes. But on 7, you're actually finding a cost of something. So I'm not going to explain too much about 7 because I want you to think about this. Number 7, you should be able to relate to. It's about a cell phone bill. Now, I know you guys have no clue, all right, because you don't pay your own. But trust me, your parents understand this, okay? Now, most of you have unlimited text message. Well, most of you don't even text. You use all the social media that you shouldn't be using to do it through. But anyway, you can pretend, all right? So what 7 is setting up for you is a scenario where you have only 55 text messages that you're allowed to send in a month. Most of you do that in a day, if not an hour. I know, Liberty's looking at me like, what? But anyway, you can still wrap your mind around this. 55 in a month. If you go over 55, you have to pay 25 cents per text message. All right? Your parents should do that.
I'm gonna be in a lot of debt.
Right. So you're figuring out for the months of January through April, okay, how much extra they would have had to pay for text messages, but they only have to pay once you get over 55 messages. So what are the only 2 months they end up paying? Adam?
January, February.
Yes, and you have to figure out how much they would pay. So you get 55 for free a month, but if it's over 55, you're paying a quarter per text message over 55. That's kind of all I'm going to tell you about 7 because I really feel that's something you could try to relate to. Okay? So if you had to hand your parents a quarter for every text message you sent over 55 messages in a month, with that scenario, how much money would you have to give them for January and February? That's kind of what you're figuring out. Okay? So you're doing 1 through 7, leaving it in your book. Don't tear it out. We're going to go over 5 of them tomorrow because I already did 2 of them with you. Then we'll learn how to graph inequalities, which makes understanding them so much easier. Okay? So you're doing 2, 3, 4, 6, and 7. Leave it in your book so we can go over it tomorrow. Then your IXL should make more sense. Okay? Questions? All right, let me end this real quick, then I can take questions if I need to.